everybody, I know it's been a minute since we've done a video, but I'm obviously not here today, so I'm going to bring it back. I'm going to start by going over the bell work. At this point you should have already made your first attempt, and now we're going to go over it. So it asks you to think of a solution to the following equations, or in other words, think of what x could equal. So for this first one, this is just a review of when we solved equations way back when, during our algebra unit. So maybe you thought to do something like this. To get x by itself, you want to subtract 2 on both sides, so x would have to be -7. Or even so, maybe you just realize -7 is what x needs to be in order to get -5 when I add 2 to it. But this next one is a little bit different. There's x's on both sides of the equation. So what could x be? They have to be the same thing because they're both x. If they're the same variable, they have to represent the same quantity. So what could x be? Well, what if x was 0? 0 plus 1 equals 0 plus 1. So x could be 0. If x was 3, 3 plus 1 is 4, 3 plus 1 is 4. So you should have hopefully thought x can be anything. It doesn't matter because the sides are equal. So x can be any number. And then this looks like an equation that we saw with our exponents or our square root unit. And to get x by itself, right now it's being squared, so to undo that you'd want to square root both sides, and you get x equals the square root of -9, which hopefully you remember you can't take the square root of -9. Or in other words, nothing times itself is going to give us a negative number. So this means that x is nothing. There's really nothing that x can be. So far with our equations, we've primarily solved them and gotten one answer. But there's these other instances where x could be anything, x could be infinitely many solutions, or x could be nothing. There's no solution that x can be. So our topic for today is solving equations with either one solution, no solutions, or infinitely many solutions. So once again, just taking it a step further with our solving equations topic that we did in 7th grade. So I have some steps to follow just when we come across our equations now. So our equations are going to be much more complex. So when I have the equal sign in the middle, there might be a lot going on over here and a lot going on over here. So the first step is to simplify what we can. Okay, if there's like terms on this side of the equation, combine them, simplify them. Same as if it's over here. And then it says to combine like terms on both sides of the equation. Okay, there might be x's, so once again, if this is the equal sign right here, there might be some x terms on this side and some x terms on this side, just like in the second example on the bell work. So if that's the case, you'll have to combine those from one side to the other, and I'll show you what I mean by that. And then from there, determine if the equation has one, many, or no solutions. So one, we'll get just like what we normally do. X will equal some number. No solutions will occur if one number equals a different number. So for example, if you get 0 equals 5, well 0 doesn't equal 5, so the equation came to a conclusion that doesn't make sense. Also, if it's a problem like the bell work and you get x equals the square root of a negative number, we know that that is not a solution either. And then many different solutions will be the answer if a number equals itself. If you get 0 equals 0, that's a true statement. If you get 1 equals 1, that's a true statement. So that will show you that there's infinitely many solutions. So let's go through some examples and see what I mean. first one is actually a normal equation, one that we've seen before. There's no simplifying that I need to do. There's just one x on this side. So solve it like we know how to solve equations. We want to get rid of this plus 6 by subtracting 6 on both sides. That cancels that out, leaving me with 2x on the left equal to negative 14 plus negative 6 or minus 6 on the right, which is negative 20. And from here, x is being multiplied by 2, so we divide by 2 on both sides, leaving us with x equals negative 10. Negative 20 divided by 2 is negative 10. So once again, that's just a review. This one is actually a review as well. This is an equation in factored form where we could solve this by distributing in the negative 3, or we could undo the multiplying by negative 3 by dividing both sides by negative 3. I'm going to do it that way, but if you want to distribute and see if we get the same answer, you can do that as well. So, like I said, x is being multiplied by negative 3, so to undo that, I'm going to divide both sides by negative 3. The times and the dividing by negative 3 cancel out, leaving me with just this x plus 1 equal to 15 divided by negative 3, which is negative 5. And from here, subtract 1 on both sides. Minus 1, plus 1 and minus 1 cancel out, leaving me with x like we want. Negative 5 minus 1 is negative 6. So x equals negative 6 there. So once again, both of those are a review. We got to one solution. But this next one is a little bit different because I have x's on both sides of the equations. There's nothing I can simplify on either side, but I do want to get all of my x terms on one side of the equation and all of my constants, my numbers, on the other side. So it doesn't matter where you start. I'll start by moving this 3 over on this side, so I'll put the numbers over here and the variables over here. And we still are going to do what we know we can do. So for example, right now I'm subtracting 3 here, so to undo that, I'm going to add 3 on both sides. Minus 3 and plus 3 cancel out. I'm left with a 6x over here. 7 plus 3 is 10, and then I also still have that plus x here. So after that step, I'm left with x plus 10 equals 6x. So once again, I have x's on both sides of the equation, and I don't want that. So I've got my numbers on this side, so let's get rid of the x, move it over to this side, and I do that just like I know how to solve equations. To get rid of a plus x, I can subtract x on both sides. So a positive x and a negative x cancel out. That leaves me with 10 equal to 6x minus x is 5x. And from here, x is being multiplied by 5. So to undo that, divide both sides by 5. And you get x equals 2. So once again, in an equation like this, where there's x's and terms on both sides, move the x's over to one side, the numbers over to the other. All right, here we have another pretty complex equation, and this is one where I want to do some simplifying first. So here, if you look on this side, I have a negative 4x and a 7x that I can combine. I also have a negative 10 and a positive 2. Negative 4x plus 7x is 3x. Negative 10 plus 2 is negative 8. So this side of the equation becomes 3x minus 8, and then there's no simplifying that I can do on this side. This just stays negative 6x plus 1. So once again, I get to an equation where there's variables and numbers. on both sides. So let's move them over. It doesn't matter if I put all the x's over here and the numbers over here, or vice versa. It's just whatever route you want to take. I always like to add things on both sides. So here I see that it's a negative 6x. So to undo that, I'll add 6x on both sides. So that cancels it out over there. I'm left with 1 equal to 3x plus 6x is 9x, and then I still have that minus 8. So since I moved the x's over here, that means I want to move the numbers over here. So I want to get rid of the minus 8, and by doing that I would add 8 on both sides. So minus 8 and plus 8 cancel, leaving me with 9x equals 1 plus 8, which is 9. And last but not least, to get x by itself, right now it's being multiplied by 9, so divide both sides by 9, meaning x equals 1. All right, so for this one, 2x plus 5 equals 2x plus 10. Once again, there's no simplifying that I can do on either end, but there are x's and numbers on both sides, so I want to get rid of that. I'll start by moving this 5 over. So to get rid of, a plus 5, I can subtract 5 on both sides. Plus 5 and minus 5 cancel. I'm left with 2x equals 2x plus 10 minus 5 is 5. And then from here I have the numbers over here now, so I'll move this 2x by subtracting it from both sides. So on the right side it cancels, leaving me with a 5. Set it equal to 2x minus 2x, which is 0. If I have 2 x's and I take away 2 x's, I'm left with 0. So this equation, it ends up being 0 equals 5, which we know is not true, which up there it says if you have a number equaling another number, this is no solution. There's nothing that x can be for this to hold true, which makes sense because whatever x is, you're multiplying it by 2 on both sides, but you're adding only 5 to it here and only 10 to it here, and 10 to it here. So the one on this side will always end up being 5 more than the one on this side, which makes sense to why it would be no solution. You can never get those to be equal. Sorry for the technical difficulty there. We are moving on to this example where there's one of two ways to approach this. Both sides are being multiplied by 3, so you could divide both sides by 3, or you could distribute in the 3, which I think I'll do it that way. So if I distribute in the 3 on both sides, I'm kind of simplifying both sides, this becomes negative 6 plus 3d equals 12 plus 3d. So once again, I have variables and numbers on both sides of the equation, so I want to put them all together. I'll start by getting rid of this minus or negative 6 by putting a positive 6 on both sides. That leaves me with 3d on the left equal to 12 plus 6, which is 18, and then I still have the 3d on this side as well. This looks very similar to the one we just did. To get rid of the variables on this side, I'll subtract 3d from here, and whatever I do on one side I need to do to the other. So once again, I'm left with 18 on this side equal to 0. And does 18 equal 0? No, meaning there are no solutions. Once again, there's nothing that D can be that would have this equation hold true. This equation, 3f plus 4 equals 3f plus 4. You might know what's going to happen here, but I'm going to walk you through it. We have variables and numbers on both sides, so we'll put them all together. I'll start by putting the numbers together, subtract 4 on both sides. That gets rid of the 4 over here, leaving me with 3f equals positive 4 and negative 4. It actually cancels over there as well. 3f equals 3f. And then from here, you could divide both sides by 3 or subtract f on both sides. Either way, I'll divide both sides by 3. Then you get f equals f, so whatever f is, it's going to equal each other. Something is equaling itself, which means we're going to have infinitely many solutions. Okay, because the same exact thing is on both sides, f can be anything, because no matter what, I'm going to take it, I'm going to multiply it by 3, and then I'm going to add 4 to it. So it makes sense that it would be infinitely many. Here we have another one, but we do need to do some simplifying on this side. Once again, I could divide both sides by 2. I'd have to divide this whole thing by 2, or you can distribute, which I'm going to do. So 2 times 3j is 6j, plus 2 times 2, which is 4. So you have 6j plus 4 on that side equals 6j plus 4 on this side. Maybe you see what's going to happen. If you want to stop here and write the answer, you can. But technically, from here, if you subtracted 4 on both sides, it gets rid of them. Same thing, that leaves us with 6j equals 6j. Once again, you could divide both sides by 6, or you could even subtract 6j from both sides. I'll show you what that would look like. You subtract 6j, subtract 6j, then those cancel. Then you're left with 0 equals 0. Once again, 0 does equal 0, always. So this is another infinitely many solutions answer. J could be any value, and the equation would hold true. And lastly, we have this big long equation that needs some simplifying to happen first. So over here we have 10x and negative 2x that can be combined, along with 3 and 4. Therefore, this equation becomes 8x plus 7 equal to 8x plus 7. Once again, we end up having the same thing equaling the same thing, and hopefully without even doing any more work, you know that this has infinitely many solutions. So hopefully you kind of saw a pattern between the equations with no solutions, infinitely many solutions, and one solution. So that's what I want us to write down here. How could we tell whether an equation will have 0 or many without completely solving it? And hopefully you noticed if we simplify to the equation to where there's a variable and a term on both sides, if they end up being the same, it's infinitely many. If they have the same variable term, but a different constant, that's when there's no solutions. So for this one, it was 2x plus 5 equals 2x plus 10. Here it ended up being negative 6 plus 3d equaled 12 plus 3d. So it was the same variable term, but a different number. Therefore, to answer this question, how can we tell if it has 0, Once again, the equation will have the same variable term on both sides. With different constant terms. So for example, 6x plus 2 equals 6x plus 5. Same variable term, different constants, that's going to be no solution. It will have many, infinitely many solutions when it has the same variable term and the same constant. On each side, or on both sides of the equation. So, for example, 6x plus 1 equals 6x plus 1. If it simplifies to that, or if it just is that, it'll be infinitely many solutions. And then, of course, if it's different and different, then it'll have just one solution like we've seen. So on the back side of these notes, you're going to come up with your own equations, okay? Come up with one that has infinitely many solutions, come up with one that has no solutions, and come up with one, or two actually of each, that has one solution. You can have something like this for one of them, but I want the other one to require some simplifying to get to this point. Okay. So good luck, check those answers with the partner, and then your homework is what's last.